We'll focus on a couple of special reactions, and the first one is precipitation reactions. It's any reaction that would produce a solid substance out of the reaction medium. So it will precipitate a solid out of the reaction medium. So what happens, for example, when you combine lead ions with iodide ions, is that lead and iodide combination has a very low solubility in water, so it will deposit as a solid in the solution or the medium of the reaction. And it can be described by this equation here. It's a combination of lead ions with iodide ions to make an insoluble combination of lead iodide that will deposit out of solution as a yellow precipitate, as you can see in the picture right here, right? Determining which combination will be insoluble or will deposit as a precipitate out of the reaction medium depends on a set of rules called the solubility rules. It tells you which combination is going to be soluble and which combination is going to be insoluble. In general, all group 1 elements in the periodic table are always soluble. So salts or combinations with group 1 elements or ammonia are always soluble no matter what anion you're combining it with. And second set of always soluble salts of nitrate, acetate, bicarbonate, chlorate, and perchlorate. All these anions are always soluble no matter what cation it will combine with, right? Halides are always soluble unless they are combined with silver, mercury, or lead. Sulfates are always soluble unless they're combined with one of this set of cations here, right? On the other hand, we have a group of ions that are always insoluble with some exceptions. Carbonates, phosphates, chromates, and sulfides are always insoluble, except if they are combined with group 1 or ammonium, which is basically an application for that rule right here, which says group 1 and ammonium are always soluble no matter what anions you combine with. Hydroxides are always insoluble unless they are combined with alkali metals, again, an application of this rule, or barium, okay? So we can use these rules here to make a prediction on the solubility of a certain group of substances or a certain combination of ions together. So if you combine sodium with phosphate, you can look at the rules here. Sodium is one of the group 1 elements, which says its combination of sodium with any anion will be always soluble. So we denote that it's soluble with AQ, standing for aqueous, or soluble in water. If you look at the second combination, it's chloride with lead. So we look at the rule for halides, and chloride is one of them. Chloride or chloride salts are always soluble unless it's combined with one of these 3 ions. One of them is lead. So the combination of chloride with lead is insoluble. So we write down S, standing for solid. So it's not gonna dissolve in water. Copper with this species here is something you don't need to know what is it, because if it's not one of the soluble species, the soluble anions, you don't care, right? You don't care what is the identity of this anion, since it's not one of the always soluble anions. That means that it's gonna be insoluble, right? And the last example is the combination of magnesium with hydroxide. Hydroxides are always insoluble unless it's combined with group 1 or barium. Magnesium is neither of them, which means this combination is gonna be insoluble. How to describe the precipitation reactions and how to actually predict the outcome of a precipitation reaction even without being given the information. So if you combine silver nitrate with potassium chloride, what you expect is that, as we said, the cation of the first salt is going to combine with the anion of the second one, and the anion of the second salt, the cation of the second salt is going to combine with the anion of the first one. So it's going to give us AgCl plus KNO3. Then we can make a prediction about the physical state. Is this combination is going to be soluble or not? That's an easy combination because it's a salt of group 1 element, so always soluble, right? This combination here, if we go back to the rules, it's a combination of chloride with mercury, which means it's an insoluble combination, right? So we go back, this here is going to be an insoluble combination. So we can make the same approach here to predict the outcome of this combination of substances here. Again, cation of the first salt with the anion of the second, cation of the second with the anion of the first will give us BBS plus NH4NO3. Again, prediction about the physical state of the outcome. This is going to be aqueous. It's a salt of ammonium and nitrate, which both are always soluble, right? This one here, if you go back to sulfites, sulfites are always insoluble unless it's combined with group 1. Lead is not a group 1 atom, so that combination is going to be insoluble, right? These equations that we just wrote are called the molecular equation describing the process. But again, they don't give us the whole picture of what's actually taking place. As we said, the whole picture is going to be much more clear if we describe what actually takes place in terms of the splitting of ions. Any substance that dissolves, any ionic substance that will dissolve in water will split into the corresponding ions, which means silver nitrate dissolves in water, so it's going to split into Ag plus ions plus NO3 minus ions. Same thing will happen to KCl, K plus Cl minus, and then K plus and NO3 minus. Can see anything that is insoluble will mean that it's gonna stay as it is. It's not gonna split into the corresponding ions. The ions will remain attached to each other. So anything that is solid is gonna stay as it is with no splitting or dissociation. So what we can see here in terms of the change for each of the ions, we'll find that nitrate ions were soluble and they stayed soluble after the reaction was complete, which means no change affected nitrate ions whatsoever. Same thing for potassium. Potassium was soluble, and after the reaction took place, it stayed as it was. So these two ions are called spectator ions. They didn't actually get affected by the reaction at all. They don't participate in the reaction at all. But if you look at silver ions were soluble and chloride ions were soluble, and after the reaction took place, they actually combination started to become insoluble. So those are the ions that actually underwent a change during the reaction. Those are the core of the reaction. So to accurately describe what exactly took place during this reaction, it's a combination of silver ions that were soluble with chloride ions that were soluble to make silver chloride precipitate. Same thing for the second example here. If we apply the dissociation rule or the splitting rule for anything that dissolves in water. This substance is soluble in water, so it's going to split into the corresponding ions, 2 nitrate ions. And this substance is soluble in water, same thing, is going to split to the corresponding ions. Here, ammonium is going to split, it's soluble, and nitrate. That combination here is not soluble, so the ions will stay intact in the solid phase and they will not split. So the substance will stay as a solid phase substance. So again, if we look at each species, we will find that nitrate didn't undergo any change during the reaction. Ammonium didn't undergo any change. So what actually took place in this reaction was the combination of lead ions plus sulfide ions to make lead sulfide precipitate. So the first equation here is called the molecular equation. Second equation is the total ionic equation. And the third equation, the last one, is the net ionic equation that tells you the actual reaction that takes place during the process. Again, let's practice one more example here. If you combine barium chloride with potassium sulfate, you start with barium chloride. From the solubility rules, if you go back to the table, this substance is soluble. And you combine it with potassium sulfate. So it's potassium sulfate. Again, that's a soluble salt because it's a salt of potassium, which is a group 1 element. You combine them. What happens is that the cation of the first salt goes with the anion of the second, and the cation of the second goes with the anion of the first. So you expect barium to combine with sulfate and potassium to combine with chloride, and we'll have 2 of those, right? Second step is predicting what type of physical state are these 2 products gonna be. Potassium is an easy choice here. It's gonna be soluble. It's a group 1 element. And barium sulfate, if you go back to the solubility rule table, you will find that sulfates are always insoluble. So that is going to be an insoluble combination. This is here is the molecular equation for this reaction. Total ionic equation is going to be splitting anything that dissolves in water into the corresponding ions. So that's a soluble substance that is going to split to barium ions plus chloride ions. Same thing here, potassium ions plus sulfate ions. And same thing here, potassium ions plus chloride ions. This substance is the only thing that doesn't split because it's going to stay as a solid phase substance where the ions are going to stay together, right? So again, we look at what happens to each ion. We'll find that chloride didn't change, potassium didn't change. So those are 2 spectator ions. And what actually takes place here is combination of barium ions to sulfate ions to make a solid precipitate of barium sulfate. And that last thing here is the net ionic equation that describes the exact actual reactions that takes place in this case.